Okay, review over radicals and geometry. So, got the square root of 40. That needs to be simplified. That is not a perfect square. So the square root of 40 we know is going to be an irrational number. So then we simplify it by dividing and seeing which one of these perfect squares goes into 4. 40, excuse me. So 36 isn't going to work. 25 isn't going to work. 16 is not going to work. 9 is not going to work. Then 4. So that works. So I rewrite that as the square root of 4 times the square root of 10. So the square root of 4 equals 2. So the answer to this is 2 times the square root of 10. Okay. Okay, in the next problem we have the square root of 72 times x to the 5th times y to the 7th. Okay, so now we have the square root of 72, but then there's variables in the square root too. So with multiplication, you can break up the square root into multiples. So you're going to have the square root of 72, the square root of x to the 5th, and the square root of y to the 7th. Okay. So 72, just like 40, is not a perfect square, so I put in the irrational sign. And 72 divisible by 64, yes. Or no, it's not, sorry. Divided by 49, nope. By 36, yes. Now, be careful here. 72 is also divisible by 9, and it's divisible by 4, but you need to divide it. You need to divide by the highest perfect square possible. Okay. Just going to rewrite that as the square root of 36 times the square root of 2. Then the square root of 36 turns into 6. Okay. So in my square root, I have 6 times the square root of 2, but now we have the issue of the variables. So the x to the 5th, now we don't know what the x value is, but we know at the exponent 5, we can break that into 5 factors of x. 5 of them. And then we're going to break up the square root further. Remember, multiplying, you can always break up the square root so it covers 2 of these at a time. So x times x is x to the 2nd. Then the square root and the 2nd cancel, giving me x. X to the 2nd cancels, giving me x. So we have x times x, which is x to the 2nd, then the square root of x. So because that one doesn't cancel, so we're going to put x to the 2nd outside, and then x inside. Now the y to the 7th, okay, y times y times y times y times y, 3, 4, 5, 6, 7. Okay, so 2 at a time, 1, 2, 3, 4. So y times y is y second, that's y. Y times y is y second, so y. Y second, that's y, and then this doesn't cancel because it's not y to the 2nd. So y times y times y is y to the power of 3, and then the square root of y. So we're going to put y to the 3rd outside and y inside. Okay. Okay, the square root of 2x to the 5th power times 10x. So multiplication of square roots has 3 steps. Okay. First, again, step 1, you multiply the outside coefficients, if there are any, which in this one there aren't any. There's no outside coefficients. And then you multiply the square roots. Okay? So, there's no outside coefficients, it's just the square root. So we take 2 times 10, which is 20. And then x to the 5th times x is x to the 6th. Okay. Now we simplify our new square root. Okay. So I put the square root of 20 and the square root of x to the 6th. Okay. So 20 is an irrational square root. Okay. So you put the division sign in. And you see what 20 is going to divide by. Is it divisible by 16? No. Is it divisible by 9? No. So 9's a no. How about 4? Yeah, obviously it's 4 and 5. So we write that as the square root of 4 times the square root of 5. So the square root of 4 equals 2. Okay. So this is equal to 2 times the square root of 5. So in our new square root, we put a whole 2 factor there, and then the 5 factor stays in the square root. Then x to the 6, we got x times x times x times x times x times x. So 2 at a time. So x second, square root and the second cancel, giving me x. Cancel, giving me x. And this is x to the second, and that gives me x. So x times x times x is x to the third. Now, I didn't have a square root remaining, so this x to the third goes out. Okay? We don't have any x's inside. And then step 3, a lot of times you don't have to do anything. It depends if you can simplify the outside, which we can't, because 2 times x to the third, since we don't know x, that's going to stay the same. There's your answer. Okay, next problem. 3 times the square root of 5 plus 4 times the square root of 20. Okay, now adding's a different story than it is multiplying. It's, you do this, if you try to do this the same way you're doing this, it's all completely wrong. Okay, you won't get any points on this. Okay, addition, you have to find like terms. To be able to add in algebra, you need like terms. So the 3 is multiplied by the square root of 5, the 4 is multiplied by the square root of 20. Since they're not multiplied by the same thing, they can't be like terms. So what we do is we make a table and see if these can simplify so that they are like terms. So the square root of 5 is irrational. It's an irrational number. And the only thing 5 is going to be, that the only one of these perfect squares that goes into 5 is 1. Okay? So, therefore, this will just stay the same, because if the only thing that goes into it's the square root of 1, it's pointless, because the square root of 5 divided by the square root of 1 is the square root of 5. Okay, then the square root of 20. 20 is not a perfect square. That's irrational. So we put in the division sign. We'll carry down the 4. And then 20, it's not divisible by 16, nor is it divisible by 9, but it is divisible by 4. So I rewrite that as the square root of 4 times the square root of 5. So the square root of 4 is 2. Okay? And then, sorry, I should have done this here. That's where I always do it. 4, sorry. Square root of 4 becomes 2. So instead of 4 times the square root of 20, it's 4 times 2 times the square root of 5. And of course, 4 times 2 then is going to multiply to 8 times the square root of 5. So, this doesn't change. That's already in simplest form. Okay? 4 times the square root of 5 turns into 8 times the square root of 5. So you got the square root of 5, because both of them now are like terms. Okay? And then 3 plus 8 is 11. Okay? So 11 times the square root of 5. Okay, now rationalize the denominator. Rationalize means get rid of the square root. That's what that means. Now look at your square root. Is there anything being added to the square root? No, there's not. So then when I multiply, I just multiply by the square root of 2. Okay, now down here, so I'm going to set up my top, split this up, top and bottom. So 10 times the square root of 2 on top. Now if you want to put a 1 there, remember you can't take 10 times the square root of 2, but you can put a coefficient multiplier 1 there and take 10 times 1. So it's going to be 10 times 1 times the square root of 2. Now on the bottom, the square root of 2 times the square root of 2, you can put 1s in front if you want. Okay, so then you can see, okay, it's just 1 to 1. Okay. But it's 1 times the square root of 2 times 1 times the square root of 2. There's no plussing, there's no adding going on, so it's just one multiplication on the top and the bottom. 10 times 1, and then the 1 needs the times square root of 2. 1 times 1, and the 1 times the square root of 2 times 1 times the square root of 2. Okay, so 10 times 1 is 10 times the square root of 2. 1 times 1 is 1, and then the square root of 2 times the square root of 2 is the square root of 4. Now we see if those can be simplified. That's the top, that's the bottom. Okay, square root of 2 is irrational, is not a perfect square. The only thing that really goes into 2 for perfect squares is 1, so that's going to stay the same. Okay, so the square root of 4, that's not irrational. The square root of 4 is equal to 2. Okay, so then it's 1 times 2, and 1 times 2, of course, is equal to 2. Okay, so we're going to put a 2 down here. Now, I'm going to divide the 10 by the 2 because 10 divided by 2 is not a decimal. 10 divided by 2 is 5. If you divide these two numbers and get a decimal, just circle it and leave it. But if this divides evenly by 2, 2 goes into 10. I mean, the square root of 2 right here I just have. But 10 divided by 2 is 5, so the answer is 5 times the square root of 2. Now, if those divide into a decimal, just circle this, okay? I'm going to repeat that. If these divide into a whole number, write it, but if they divide into a decimal, just circle what you have right there. Okay, the next one's another rationalize the denominator. You have this irrational square root in the denominator. You need to get rid of the square root. But since the square root has a whole number being added to it, or if it has something being added to it, you use the conjugate rule. So that means when it's something being added, you want to make a parentheses. You make a parentheses now on your new fractions, instead of just taking a square root with the 1 in front. So we're going to keep the square root of 5 the same. We're still going to have addition, but instead of a 2, that second term is going to become its opposite. And then this is square root of 2 plus 5 plus negative 2. Okay, now we're going to multiply. So we have 8 here. I'm going to put a 1 there, circle the plus, so I can see what I'm distributing. So I distribute 8 to 1 times the square root of 5. Yeah, 8's distributed to 1, but the 1 still has the square root of 5. And then back to the 8, we got to take 8 times negative 2. And I'll figure that out. Now I'm going to set up my bottom. So these plus signs here. Remember, the square root of 5, I would suggest putting a 1 out front so you can see, okay, I got to distribute 1 to 1 and 1 to negative 2. But it's 1 times the square root of 5 times 1 times the square root of 5, and then 1 times the square root of 5 times negative 2, the integer. Okay, and that's done. Then I repeat the same process with the 2. So 2 to the 1, 2 times 1 times the square root of 5, and then 2 times negative 2. Okay, so this is going to be 8 times the square root of 5, and this is going to be negative 16. Now here you're going to have 1 times the square root of 25, and then negative 2 times just the square root of 5, and then positive 2 times the square root of 5, and then that's just going to be a negative 4 integer. So on top, remember, this is my answer. I've got 8 times the square root of 5 and negative 16. Then on the bottom, I got 1 times the square root of 25, negative 2 times the square root of 5, positive 2 times the square root of 5, and then negative 4. Okay, now simplify them. That'll be your top. So we got 8 times the square root of 5. Well, the square root of 5 is irrational. Okay, it's definitely irrational. So we put in the division sign, drop your 8, okay? But the only thing that goes into the square root of 5 is 1, so don't divide, it's just 8 times the square root of 5, simplified. And negative 16 is an integer, so it's simplified. Now the 8 and the negative 16 cannot be added, okay? You put the plus in, but they can't be added because they're not like terms. So I just on top, I write 8 times the square root of 5 plus negative 16. Now, down in the denominator, okay, we have the square root of 25. Well, that's not irrational. The square root of 25 is 5, okay? So it's 1 times 5, and that's 5. Now, there's no point in simplifying these since they're just conjugates, because if you added those, remember, all this is added. These are both multiplied by the square root of 5, and you got a negative 2 and a positive 2, which cancel. Then this, of course, is in simplest form. Now these are both integers. We add them. That's 1. Okay? Put the 1 down. Now, really, when you end up with 1, you see 8 divided by 1 is 8. Negative 16 divided by 1 is negative 16. So you can leave it like that. I don't care. But you could also divide your whole numbers. Okay? Because you see 8 divided by 1 is 8, but it would be times the square root of 5. And then negative 16 divided by 1 is negative 16. You can either go with this or this. And also on top with this one, I wouldn't count you off if you just stayed with this. Okay? But you should only be dividing if it's a whole even division. Okay, sorry about not writing directions on this one. You are to solve the equation. That means you got to find what value the variable has. So you got the square root of 7x minus 4 equals 12. Well, when the variable we're trying to solve for, x, is in a square root, we have to solve for the square root, and then we have to solve for the variable. So first we solve for the square root, then we solve for the variable, which in this instance is x. Okay. So the square root's on this side. Well, there's nothing outside of the square root, so I can go right to my second power. That's all I have to do to solve for the square root. Okay. So I eliminate my square root, second power. That cancels on that side. Then 12 to the second power is easy to evaluate. You can evaluate that, and it's 144. Okay. Now at this point in the problem, you're solving for x. Now you have x only, so you're going to use linear properties. So there's one answer. So linear properties, you're just getting rid of the operations on the x. You got times and minus. Get rid of your minus with plus 4. 144 plus 4 is 148. Divide by your 7. So 148 divided by 7. I don't want to see that. Hit second PRB. 21 and 1/7. Now, if you're like, well, I don't think that's right, well, write the original problem. The square root of 7x minus 4 equals 12. Now, substitute 21 and 1/7 in for x. Okay, 7x. Now it's going to be 7 times 21 and 1/7 minus 4 equals 12. So first I'm going to multiply 7 times 21 and 1/7. That's 148. 148 minus 4 is 144, so the square root of 144 equals 12. Now 144 is not an irrational square root, it's equal to 12, and then 12 equals 12, so yeah, that's right. Okay. Alright, next one, the square root of 8x plus 5 equals 13. Okay, so you're to solve for the square root, and then you're going to solve for your variable, which again is x. Okay, so here's the square root, but you got an operation outside the square root this time. Yeah, you're going to do the second power, but you got something you have to do before then. The opposite of plus 5 is minus 5. Okay. Now, if there's a number in front, that's times, and you divide to get rid of that, but there's no number in front of the square root, so we minus the 5. So the square root of 8x, and then 13 minus 5 is 8. Now get rid of your square root with the second power. That cancels, and we have the expression 8x, which means 8 multiplied by x. 8 to the second is easy to evaluate. 8 times 8 is 64. Okay, then divide by 8, and x equals 8. Oh, sorry, I didn't write down what it was. X. When I got rid of the square root, I had x only. So it was linear properties. Sorry, I forgot to do that. Answer's still 8, but you should be writing that. Okay, so if you want to check your answer, you write the original problem. Square root of 8x plus 5 equals 13. Well, I'm going to substitute, I think 8's the answer for x. So this x here is replaced with 8. So instead of 8x, it's going to be 8 times 8 plus 5 equals 13. So 8 times 8 is 64. The square root of 64 is equal to 8, so it's not irrational. And then 8 plus 5 equals 13. Is 8 plus 5 13? Yes. Okay. So it checks out. Okay, next one is a little bit harder. X minus 3 equals the square root of 10x minus 54. So again, solve for square root, solve for x. The square root's over here, there's nothing outside of it, so we just go right to our second power. That will take out the square root. But then the other side, we put a parentheses, second power. Now, over here you got 10x minus 54. Now, over here where we didn't have the square root, we can't evaluate on this problem because the inside to the second power, the base is a variable. It's a binomial to the second power. So with the x, what you do is you get rid of the second power and you make another parentheses just like it, because that's what a second power means. It's just the base times itself. Now, you need to execute your FOIL method here. So we take 1x times 1x and 1x times negative 3. Then we take the negative 3 times 1x and the negative 3 times negative 3. So that's going to be 1x to the second power, negative 3x, another negative 3x. Guys, these don't cancel. They're both negatives, okay? Cancel. The middles cancel if it's a positive and a negative. They're both negatives. Then 9, okay? So for x second, we got 1. Negative 3's add up to negative 6, and then you got 9. So you bring that over here. And we have x second, and we have x. Well, now we can't use the linear properties method. We have to use the factoring properties method. Now here's what I get sick and tired of seeing. Okay, there's two answers, by the way. People will just take that and GCFT it. Well, why would you do that? You're just going to end up back here. Okay, that's stupid. You GCFT it after you clear one side of the equation, because when you factoring properties is when you do the F1, F2 equals 0. Well, you can't do that unless you have 0 on one of the sides. So, clear the side without the x second, that one there. So subtract 10x, and then you would subtract that from the negative 6x, and that is a negative. Then plus 54 to your 9. So then, I set my equation. Now I know my equation is equal to 0. So you have 1. Negative 6 minus 10 is negative 16. 9 plus 54 is 63. Okay, so GCFT. Okay, no x, no net 1's a GCF. Then the AC product, 1 times 63 is 63 positive, so the signs have to match. And they have to add to the B value, negative 16. So start dividing. 1 and 63, that adds a negative 64. That's not even close. 2 doesn't go into 63, it's a decimal. 3 does, 3 and 21, but that's not it. That's negative 24. So you're still wide. 4 doesn't go into 63. Neither does 5. Neither does 6. 7 does, 7 and 9, and I think that's there's your negative 16. So put in your factors. Negative 7, negative 9. Now the A, the x second, that's just multiplied by 1, so we know what's going to happen there. Place the 1's in front. Okay, you can't, those stay in simplest form. Then if we end up with multipliers of 1, we don't need those. Okay, so it's x minus 7, x minus 9 equals 0. So F1, F2. So x minus 7 could equal 0, or x minus 9 could equal 0. So we add the 7 to both sides, and that's 7. Add the 9 to both sides, and that's 9. Now, the reason why there's two answers is this, okay? This was the original problem. Actually, never mind that, okay? You could do it the same way. You could plug in the 9. Yeah, I'll just check the 9 and then leave it. I'll check the 9 and the 7, I guess. So, I'm going to replace both my x's with 9, so that's going to be 9 minus 3. And then 10x is going to be 10 times 9 minus 54. So that's 6. Now 10 times 9 is 90, and then 9 minus 54 is 36. The square root of 36 is equal to 6, so 6 is equal to 6. Check. Okay. Now if you check your other answer, and put the 7 in, 7 minus 3, and then put the 7 in over there. So that's 4. That'd be 70. 70 minus 54 is 16. And the square root of 16 is equal to 4. Okay, so 4 equals 4. That checks. They both check out. You don't have to do that, I'm just saying. Okay, find the distance between the 2 points. So, distance is measured in units. Distance. It's basically the distance is the c in the Pythagorean theorem. Now, a squared plus b squared equals c squared, but the a is x minus x to the second. It's finding the distance between the x's, plus b squared, which is going to be our y minus y to the second, and the square root's over it because it's c second, okay? Well, a second power leads you to solve for it, you have to square root, okay? So, put those values in. So x minus, start with the higher x. So put in your 7 there, put in the negative 4 there. And then 2 and 8. So 7 minus 2 is 5. Excuse me, 5. Negative 4 minus 8 is negative 12. So you have 5 to the second plus negative 12 to the second. You need, if that's a negative, it needs to stay in its parentheses. Okay. Okay, 5 to the second, 5 times 5, that's 25. Negative 12 to the second. If you put negative, it's wrong, okay? That's 144. So then the square root of 25, so then 25 plus 144 is 169. And we get lucky on this one because the square root of 69 is not irrational. It's equal to 13, okay? So D is equal to 13. 13 whole units. Okay, no square root. Okay, find the midpoint of the segment with the given endpoints. Now this looks like the same as the last one, but this is midpoint. Put midpoint or mid or m or something equals. Now that's a coordinate, okay? You're essentially finding the middle of the x's, which means adding the x's and dividing the sum by 2. Then adding the y's and dividing by the sum by 2. Okay, so the x is 0 plus negative 4, and the y's negative 5 plus 8. Okay, so this is negative 4. When you add, this is 3. Okay, actually just do that here, sorry. Negative 4 and 3. So negative 4 divided by 2 is negative 2. And then 3 divided by 2 is 1.5. So negative 2, 1.5. Erase those if you copy down what I did. Okay, then we got the Pythagorean theorem. You need to find the unknown side. So we know it's a squared plus b squared equals c squared. C being the hypotenuse. C should be the longest side. So A we have is 10 to the second. B is unknown, so we keep that as a variable. And then 26 to the second. Okay, so 10 to the second means 10 times 10. Well, that's 100. We keep the B as a variable. 26 to the second. Probably not sure about that, so 676. Okay, time to solve for B. Use linear properties. Okay, now you have to take out this 100. Okay, so it's, you have 100 being added, so you take it out by subtracting it. That's going to be 576. Now, I realize that my square root list, I didn't go to 576 to see if it's irrational or not. You square root it on the calculator. And that's not irrational. It's equal to 24. Okay? 24. So you didn't get an irrational. The square root's not equal to an irrational number. It equals a whole number. So put the whole number. Don't sit there and divide. Okay? Alright. Last one, a squared plus b squared equals c squared. So a is unknown. That's what we're figuring out. B is 8. Sorry, equals, and c is 11. So the variable a stays the same. A to the second, 8 times 8 is 64. And then 11 times 11 is 121. Use linear properties to solve for the unknown here, because you have a to the second only. Now there would be technically two answers, but when we're finding the length of a side, we don't put that. Okay. So 121 minus 64, 57. So you find the square root of 57. Now, unfortunately, 57 is not a you can look at your sheet, you don't see 57, and the square root's irrational. Okay? So you got to put in the division sign on this one. So 57 divided by 49, decimal. 36 doesn't go into 57. 25 doesn't go into 57. 16, nope. 9, nope. 4, so the only thing that goes into it's 1, which means we're just going to leave it as the square root of 57. It's already simplified.